Guys, we are here for a second installment of groundwater, and in the first video we talked about porosity. In this video we're going to talk about permeability. So in order for water to flow through sediment or rock, the pore space needs to be interconnected, and that makes the rock permeable. So permeability is just a measure of the ability of water to flow through rock or soil. So the more permeable it is, the more likely water can flow through it. The less permeable, water cannot flow through it. And so we have an experiment set up here with the same types of marbles from the porosity video. So here we have a well-sorted sample, all the same size grains. And what Livy's gonna do is she's gonna pour water into that sample, and we're going to measure permeability, which is the rate of flow of water through that sediment. So she's going to pour it slowly. There we go. Oh, and it's spilling everywhere. Let's move that over. Okay, it's flowing pretty fast. You can see it's coming down through. Even though that's clamped, the water is flowing readily through those pores, meaning that they're interconnected and the water has the ability to find a pathway. So when water falls as rain, it's going to flow through permeable soil and rock and then be stored in pore space within an aquifer underground. Now, if we look at this experiment and we change out, I'm going to go ahead and substitute the well-sorted sample for the poorly sorted sample. Hold on, Liv.
We're pouring it right here, right?
Yep. So I'm going to go ahead and empty this out and then replace it with a mixture of different sized marbles.
I'm going to replace it.
And then Livy's going to go ahead and do the same experiment slowly. In our first video, we kind of poured it in too fast. And
so we deleted that video.
Yeah, we flooded everything. So we're going to do it really slow so that they can see the difference in permeability for this poorly sorted sample. So real slow, Liv.
That bee is distracting me.
There we go. That's good.
Can I pour a little bit
A
more?
little bit more. Okay. Oh, okay. So it's a little bit slower flow rate. There's still water flowing through it, so this is still permeable. There's a little less pore space. If you imagine this sample with even smaller grains between the larger grains, like say you put sand particles in that mixture of marbles, it would flow even more slowly. And that's because that sediment does not have connected pore space. So if you look at a well-sorted sample there on the left, you can see the arrows in blue indicate that the water is able to travel down through the pores between those sediment, making it permeable. If we were to try to do the same thing with something that's poorly sorted like this, the water doesn't have a pathway to flow. So an impermeable rock won't allow water to flow through it. Or, you know, another analogy is like the sidewalk that you, or the sidewalks, parking lots, rooftops, those would all be great examples of impermeable surfaces that lack pore space and flood easily. Whereas the soil or the ground where water is stored would be permeable. So aquifers are permeable. I'm going to keep going, but that's not exactly what I wanted to say. Aquifers have pore space. That pore space from up above is permeable, allowing water to flow down through and then be stored within that groundwater system. So more to come. Sorry I screwed that last part up, but I don't want to make a third video. So that's all we got for now. Signing off.